Governments are blocking AI models left and right. So how can you build an AI solution that is resilient to this and can stand the test of time? In this video, you will learn an important strategy for making your AI solutions regulation proof. And we will be using the latest Mistral models to explain this, so let's get right into it. To illustrate how you can build robust AI, we're going to be making use of Mistral's Document AI service. They recently released one of the best OCR models, state of the art. But what if you build an AI solution based on that model and the model gets deprecated or removed for whatever reason? Well, then you have a really big problem. To show you how you can build a robust solution anyway that can actually be resilient towards these models disappearing, we're going to be looking at an example project that I built. And this example project is actually using this Pro Git book, which is a really long handbook on Git. And I will show you that in this project, we will ingest the handbook and we'll be able to answer questions about the book, while the Mistral models will be able to guide us to specific sources within the book to make sure that the information it provides is accurate. And now, the hidden trick here is that we have a version of this application built for those new Mistral models running in the cloud, both their OCR engine as well as the AI model. But also we have a fully local version, which is using LM Studio together with a Ministral model that's running on my MacBook locally, together with an OCR model that's open sourced and also running locally. This way, you build your AI system so that you can use the state-of-the-art models when they're available, but fall back to local models when they are not. Let me show you how it works. In this repository, I'm first going to go ahead and run this example script. And this script is just going to create a small sample of the Pro Git book because the book is really long and I just want to give you a more simple example. So I'm just extracting 20 pages that describe how Git branches work. And then what I'm going to do now is I'm going to ingest the PDF. This means that we're going to be using Mistral OCR 4, a GDPR compliant service, to create an index out of the entire document. Now you can see that we have 20 pages and 171 blocks indexed. And blocks basically represent specific individual units that make up a given page. What I mean by that is if I just draw a couple of bounding boxes over one of the pages and I open the boxes here, you will be able to see that the Mistral model is able to create these logical boxes around the page. For example, it knows that Git branching with a lot of confidence is the title of the page. Next, it can recognize that this is a paragraph, for example. So that's the idea behind those boxes. And because we've indexed these 20 pages and we have all those boxes with content, we can ask our Mistral model any question. So I'm going to go ahead and ask, how do I create a branch and switch to it? Which is a very common scenario in Git. Now, of course, an AI model knows this by heart already. You don't really need the Git book, but the most important thing here is just that I show you that it can actually reference a specific source from the book. You can actually see here that when I expand my terminal window a little bit, it says, based on the provided sources, to create a new branch and switch to it, follow these steps, yada, yada, yada. And then here we can see the sources. We have 3 sources. The first one is on page 8, the second one is on page 3, and then the third one is on page 3 as well. And both of these are in block 3. So let's have a look at those 2 different pages to see where it's actually getting the answer from. So if I go ahead and open that ProGit branching. So I'm opening page 3 of this document. You might actually see here at the bottom that it's page 65, but that's according to the whole ProGit PDF book. I kind of just scoped it down to only the branching pages. But indeed, if you look at page 3, you will see that creating a new branch is the main topic of that page. And if we then find page 8, you will see that here is where it explains how to switch between branches. So it does make a lot of sense that even in this really long chapter on Git branches, which is 20 pages long, Mistral is focusing on the key points of the PDF to answer my question. And so what I can do is I can take this script and I can then, for example, say that I want to create the OCR boxes on page 3, and then we can go ahead and open that to see what specific quotes were actually referenced. Now, while the solution is nice, it fully relies on 2 Mistral cloud models. First of all, the OCR model, and second of all, the language model to answer questions. So now what if we made the solution more robust and actually used local models for both of these features? Well, this repository actually contains a way to switch to those local models. I can set my sovereign mode to local and then run the exact same pro-git branching code. And now what happens is that I'm using docTR to create the OCR of the page. It works not as well as the Mistral OCR model, but it's a great fallback if for some reason that model is not available. And after a little while, you can see that we've indexed those same 20 pages, and in this case, we have 20 blocks. So docTR does a pretty good job of OCR. However, compared to Mistral OCR, it's not able to identify as many unique blocks, and generally it might just take an entire page as a single block, which is fine because one page of content does fit within the context window of an AI model. So it works completely fine. It's just less granular than the Mistral model. But this is, of course, a difference between running models locally versus in the cloud. So now what I can do is I can ask the same question. How do I create a new branch? And why my local AI model is thinking. If you are interested in learning the latest in hands-on AI engineering, then make sure to subscribe to my channel. And then let's actually prove that it's running with local AI by going to my LM Studio. And you can see here that we are actually generating a bunch of tokens to answer the question. And now that it's done on that side, you can see here that we've got a couple of sources. So the sources are a little bit different. We do again refer to creating a new branch, but in this case, we also have a source from page 9, which is fine. I mean, the entire chapter is about creating and using Git branches. So as long as there's some overlap between what the Mistral model is doing and my local models, I think it's doing a pretty decent job. And of course, when we look at the actual answer, you can see here that it actually refers to those sources here. So if you want to build something like this, you need a good architecture for it, right? So now let me show you a high-level diagram of what the code looks like that's running behind this solution. There's really two parts to the solution. On the one hand, our EU docs ingest functions, which will take a PDF and ingest it into a local database. And then the second part of the solution is our EU docs ask features, which will allow me to ask a question about the document, and that will then reuse the database to make sure that the right answer can be given. Let's just walk through this from top to bottom so you fully understand the solution. When we have a PDF file, we check the sovereign mode that's set for the application. If it's set to local, we use docTR, which can run on a local device, or of course on the server when it's a production-grade application. But the default is that we use Mistral OCR 4 to make sure that we get the best result if it's available. Both of these use the same Python methods to create blocks, and a block is a combination of either or text, boundary boxes, a type of content, whether it's code or regular text, and a confidence score to make sure that we can maybe drop some OCR that we are not very confident about. Maybe some complex figure or diagram that was not labeled properly. And then what we do is we chunk that data. We want to split it up into pieces. If you've ever built a RAG application before, this is very similar. You want to chunk up the document to pieces so that when a user has a question, you can return just the relevant chunks. And then we actually use fast embed to create local embeddings that we store in a vector database. Here too, you could opt to use a cloud-based embedding storage and embedding method, but we are all keeping this local because it works for our use case. Then we have our EU docs ask diagram. In here, I have a user question like, how do I create a branch? This user question is then passed onto Python functions that will embed my query. This question is then passed on to some Python code that will retrieve the top blocks from that local vector database. And these blocks basically serve as numbered sources. And these blocks basically serve as our sources. We can pass these sources onto an LLM chat model, right? And we can choose here again if we want to use a cloud-based model or a local one. Which sovereign mode are we running inside this application? If it's the EU one, we pass it to the cloud-based Ministral 3B latest. But if it's local, in this case, because I'm just showing a demo, we run Mistral in LM Studio on the device. In a production-grade application, you probably wouldn't be using LM Studio for this, but you can use these Ministral models completely locally because Mistral has actually open sourced them. So when you're creating these kinds of AI solutions that work for both the cloud and local, you should consider using models that are available both as a cloud-hosted version as well as a local one. And the reason for that is that there is absolutely no behavioral difference between these two paths. Maybe the cloud-based Ministral model will be a little bit faster because Mistral uses optimized hardware for it, but in terms of the actual output of the language model, my local model does the exact same thing. So unlike the example here on the top, where we choose between Mistral OCR and docTR, where there is a functional difference, because Mistral has open sourced a lot of their language models, we can actually functionally use the exact same one, whether we are in this local mode or in the EU default mode. Now, let me give you some top tips for creating a resilient AI solution. First of all, if you have to use cloud models, at the very least make sure that you're distributing your requests across different providers. Even if you're using a very specific model like Claude Opus, Cloud Opus can not only be found through the Anthropic API, but you can also query it using Google Vertex or even something like Open Router. So even if you just use one model in your application, make sure it can be routed through different providers so that your solution can always be online. The second tip is to look for very small local models to replace a lot of the difficult tasks that you might be delegating to state-of-the-art models today. Because as you saw today, open source models like Ministral can serve very well to carry a lot of the requests that you might otherwise be spending expensive models on. Plus, if those expensive models are blocklisted for whatever reason, which has happened in the past, as you know with models like Fable, you have a good fallback to go to. But that fallback is usually not as good as the state-of-the-art models. This is just a reality that we have to accept, unlike some other YouTube videos that might claim that local models are just as good as state-of-the-art. It's not the case for most use cases. But if you document the difference in performance well, then users can actually be fine with this. You just need to be able to understand and research what the performance differences are between those cloud models and the local variants that you're building. If you want to build AI solutions like this, make sure to check out my AI Native Engineer program in the link in the description below. And of course, check out all of the models that I used in the description as well.